We are the Bubble Dragons. We made a bubble machine for the freshman design project, and we shoot bubbles just like the video game.
Our goal was to create a bubble machine which produced bubbles continuously, which detached from the machine for at least a minute. It had to change the size and the frequency of the bubbles. It had to operate automatically, and it had to be portable from the table to the competition area. We also had to create our own bubble soap.
In the picture from left to right, our group consisted of Peter, Amy, Madison, and Eric. For our project, we had to research a way to control the frequency and size. After doing lots of research, we figured out the answer would be to use an Arduino and a servo.
An Arduino is a microcontroller which we coded to control the voltage to the servo and motor. Doing this would change the speed and the frequency of both these. The servo is an adjustable motor which has gears within it to allow it to be more focused on torque than speed. We used it to hold the bubble wands, which were made out of pipe cleaners, and its speed could be varied using the Arduino, which changed the frequency of the bubbles.
Here's a video of our bubble machine working on design day. As you can say, it was successful because the wands continuously dipped into the bubble solution and was continuously producing bubbles that detached from the machine. As you can see, we use pipe cleaners as our bubble wands, and behind it, everything is being controlled through the Arduino and servo. And if we wanted to change the frequency, we could do so using the code from the computer.
Here you can see the placement of the servo, the DC motor, and the Arduino, all of which ended up being hooked together using a breadboard.
Here's a list of everything we used for the project. The only thing we bought was the servo. Everything else was previously owned or found.
Here's our design process.
First, we wired the servo and the fan together to see if the circuit produced bubbles. Next, we began construction of the base that would hold the electrical components and the bubble solution. We made a track to put the fan on so that the fan could be adjustable because the strength of the air the fan produces affects the size of the bubbles.
Here's the design of the adjustable track we made. Here's a picture when we're testing the fundamental design of the bubble machine. We put the wiring on the base and controlled the fan and servo by coding it from the computer.
We had to modify the stand for the motor to allow the fan to take in air efficiently to produce bubbles. Our end product thus successfully produced bubbles by creating the optimal base to support the electrical components. We faced many challenges throughout our project. Our first challenge was finding an acceptable source of air. At first we decided to use a PC fan. However, it had many problems associated with it. It wasn't strong enough, we couldn't control the speed. So we tried funneling the air, however, that didn't work. So in the end, we decided to use a DC motor, because by combining that with the servo and Arduino, we were able to use something that could control the speed, thus controlling frequency. A second challenge was we needed to increase airflow. So we went to the craft store and cut the base, that way that allowed more air to be sucked in by the fan to increase its strength.
We designed the fan to be adjustable so we can change the distance away from the wand so that we can produce different sizes of bubbles. However, in application, it did not work well because the fan was not strong enough.
Alright, what would we do differently? If we had more money, we would buy a better air source than the motor and fan blades that we had. If we had more time, we would improve the aesthetics and make it smaller so it would be more portable.
In conclusion, our project was successful and we tied for the first place.